All right, in this video, we're going to do another gravimetric stoichiometry problem involving mass. So we have oxygen gas can be produced by decomposing potassium chlorate using the following reaction. Potassium chlorate decomposes to KCl plus O2. We do need to make sure that this is balanced, and it doesn't look balanced to me. So my first step, even before reading the question, I should be reading the whole thing. I'm going to make a balanced equation. So KClO3 solid. Heated up, so we probably would heat on the arrow, but it doesn't really matter. KCl solid plus O2 gas. That thought was there by accident. So to balance this, I'll put a 3 here, a 2 here, and a 2 here, and now we're balanced. So we have 138.6 grams of KClO3. It decomposes completely. That's important. Because we know that there's nothing left over. All our products are going to be formed and no leftover reactant. So that's good. And it's not really relevant right now. So what mass of oxygen gas is produced? So we had a mass of 138.6 grams. And we want to know the mass of oxygen that can be produced. So to find that, we need the moles times the molar mass. Remember, we can't do a mass to mass ratio. So we need to do a mole to mole ratio. So what I can do is I can find the moles of KClO3, use those moles to find the moles of oxygen, and then convert to mass afterwards. So let's go ahead and do that. Find the moles of KClO3 is equal to the mass of KClO3 from the question divided by the molar mass of KClO3. And so that's going to be equal to 138.6 grams over the molar mass of KClO3. So if we go to our periodic table, let's go there. Oops, here. Potassium is 39.1. Cl is 35.45, and then 3 oxygens, so that's plus 48 there. So we get 122.55. So 122.55 grams per mole. I just want to double check that one more time. Sometimes I don't punch in the right numbers in my calculator. So we said 39.1 plus 35.45 plus 48. Okay, I was right. Okay, so we can cross out grams and grams. So we can do 138 divided by 138.6 divided by 122.55. And we get 1.130966952 moles. So now we can use those moles to find the moles of oxygen. But first, let's make our mole ratio between the potassium chlorate and oxygen, because we're trying to find oxygen. So we know there's 2 potassium chlorates for every 3 oxygens. You can also write that as a fraction form. So for every 2 potassium chlorates, you have 3 oxygens, or you can write it for every 3 oxygens, you have 2 potassium chlorates, whether it be molecules or moles. And so now what we can do is we can do our conversion. So we'll take our moles of KClO3, so 1.130966952 moles of KClO3. Multiply that by the conversion factor that'll get rid of KClO3, which is the one with KClO3 at the bottom, and you want to keep O2, so 3 moles of O2 over 2 moles of KClO3. You can cross mole of KClO3 out like that. And so we're doing the 1.13 there times 3 divided by 2. So times 3 divided by 2, and we get approximately 1.696450428 moles of O2. So we found the number of moles. Now all we have to do is find the mass by essentially plugging it into the equation over here. So we do step 4. The mass of the oxygen produced is equal to the moles of the oxygen produced, which we calculated, times the molar mass of oxygen, which is going to be equal to the 1.696450429 moles times the molar mass of oxygen. That's 16 times 2 because it's oxygen O2, the gas. So 32.00 grams per mole. Moles cancel out there. We have grams left over. So times 32, and we get 54.2864137 grams. But we have to make sure we have the correct number of sig fig. So it's approximately, notice we have the only number here for us is 138.6. So there's 4 sig figs there. 4 sig figs in the question. So we're going to have 4 sig figs at the end. So we'll have approximately 54.29, because 4 sig figs will be here, round up to 9 grams of oxygen. And then, of course, you could make your therefore statement. So your step 5 here would be, therefore, approximately 54.29 grams of oxygen O2 is produced. All right, so that was example 7 from your handout, another mass-to-mass stoichiometry. In the next video, we're going to be doing example 8. Don't hesitate to try it yourself first and then to check the video answer key afterwards. So look forward to that in the next video.